Guten Tag, meine Damen und Herren. Ich möchte Sie herzlich zu meinem Vortrag über die Entwicklung der Energieeffizienz in meiner Firma begrüßen. Mein Name ist Wang und ich bin ein Vorstand der Johnson Electric Gruppe. Die Firma wurde 1959 von meinem Großvater gegründet und von ihm zu einer Firma mit heute $2 Milliarden Umsatz und 40.000 Mitarbeitern entwickelt. Heute bin ich hier, um unsere Geschichte mit Ihnen zu teilen. Die Geschichte, wie wir vor vielen Jahren bereits begonnen haben, Energie zu sparen und wie wir es seit 2 Jahren richtig machen. Wir haben hauptsächlich Kunden aus dem Automobilbereich, aber auch Firmen aus dem Konsumgütergeschäft zahlen zu den Abnehmen unserer Produkte. Zum Beispiel haben wir im Automobilbereich Kleinmotoren in ABS und Klimaanlagen, sowie im Konsumgutgeschäft in Kameras und Küchengeräten. Hier können Sie einen Ausschnitt aus unserer Produktpalette sehen. In jedem normalen Mercedes oder BMW sind Dutzende unserer Motoren eingebaut. Wahrscheinlich haben die meisten von Ihnen heute einen benutzt, ohne es zu wissen. Einer unserer Erfolgsfaktoren ist die hocheffiziente Produktion in Charging in Südchina. Diese ermöglicht es uns, eine hohe Kundenzufriedenheit zu erreichen, was das oberste Ziel von Johnson Electric ist. In Charging, das in der Nähe von Hongkong liegt, produzieren wir über 3 Millionen Produkte pro Tag oder anderes gesagt, wird alle 3.000 Sekunden ein neues Produkt fertiggestellt. Um dabei eine hohe Qualität und Effizienz zu erreichen, haben wir eine sehr hohe Fertigungstiefe. Diese große Anzahl an Produkten können wir nur mit dem Einsatz unserer 30.000 Mitarbeiter an diesem Standort erreichen. Die Firma ist sehr exportstark, sodass sogar Premierminister Wen Jiabao den Standort in Shenzhen besuchte. Die ganzen Komponenten für die Produkte werden bei uns produziert. Dazu gehören auch sehr energieintensive Fertigungsmethoden wie Sinten oder auch Kunststoff- und Aluminium-Spritzgüsse. Auch die Werkzeugmodifikationen an Maschinen und Errichtungen machen wir direkt im Haus. Wie Sie sich vorstellen können, ist dabei auch der Energiekonsum ein kritischer Faktor für uns. Nun möchte ich Ihnen einen Eindruck geben, wie groß der Energieverbrauch von Johnson Electric in Charging ist. Hier können Sie den Durchschnittsverbrauch eines Einfamilienhauses sehen. Die erzeugte Energie eines Kohlekraftwerks und einer Windkraftanlage ist schon wesentlich höher. Das ganze Land Togo und Afrika verbraucht 12.000 Kilowattstunden pro Stunde. Heute Johnson Electric in Charging verbraucht sogar doppelt so viel. Pro Jahr geben wir über 10 Millionen Euro für Elektrizität nur allein in dieser Fabrik aus. Neben den Kosten ist auch ein Einfluss auf unsere Umwelt und die CO2-Ausstoß ein Faktor, den wir reduzieren wollen. Zudem ist die Versorgung mit elektrischer Energie in China sehr knapp und die sich nicht selten vorkommenden Stromausfälle haben einen großen Einfluss auf unsere Produktion. Unseren Energiekonsum zu steuern ist dauernd eine wichtige Aufgabe und gleichzeitig größere Herausforderung für uns. Um Ihnen unsere Erkenntnisse und Vorgehensweisen besser und anschaulichen beschreiben zu können, werde ich den Rest der Präsentation auf Englisch halten. Die Folien bleiben weiterhin deutsch und bei Unklarheiten können Sie Fragen am Ende der Präsentation stellen. So thank you for that. I hope you understood. Hope it wasn't too painful. So I would like to tell you the story about when we started the energy saving process. In the beginning, when we started this process, we took the easy approach. We set very clear, very simple targets for 15% energy saving per year. We divided the teams into different cross-functional groups across different departments, and we measured them based on the annual savings per year. We looked at different investments you can make, various equipment, more efficient machines. We installed solar thermal water heaters for our dormitories. We did all these, let's say, normal things. And here you can see also a structure of our teams. They're cross-functional, so they go across the entire organization, from facility management to production to HR, human resources, IT, and so on. It's led by the facility management team. Now, what we found in the first few years is we had pretty good results in savings. We were able to hit that 15% every year because maybe we had a very high cost base. But as we went along, we started to realize maybe it's not so sustainable. If you look at this graph, the blue line here is our actual energy saving result. The unit is the amount of energy we use for the same amount of sales. So the lower the line, the less energy we use for sales. Now the green line was the result, the average of last year, and the red line is the target for this year, 15% lower. Now you can see here that we managed to reach that target last year in 2009. But if you look closer, it's not so comfortable. We went down, for example, from March to April to May, and then the energy consumption went up more than we saved in June, and then it started going down again in July and August, and then it went up again in October, and then it went down again. So it was not a very consistent base. And if you think about it, well, there's no reason for it to be consistent. We don't do it consistently. It's not a consistent process. So what we decided to do was to rethink this approach. And this is what we started doing 2 years, a year and a half ago. And this is the story that I want to share with you today. As we rethought it, we came up with a few important points. First, the goal is not about, let's say, making more investments, making big changes. That was before. The obvious savings we already had. Now we need to extract savings from the smaller things, from the behavioral things that don't necessarily need more money. So we need to switch the mindset from buying more machines and better equipment to really analyzing what we're doing and whether we can do it more efficiently. Second thing we realized was you cannot drive behavior just by results. I'll give you an example. If you want your children to study more, you can reward them based on their grades. You can give them money. You can pay them if they got good grades. What they'll do is they'll get very good at taking exams, but they won't get very good at learning and understanding the concepts. This is the same thing as energy saving. If you reward somebody for energy saving results, they'll be able to produce very, very good reports for those energy savings, but not necessarily really understand the processes and how to make them more energy efficient. So based on that, we decided to make some changes. The third point, you have to motivate the people and support them. You cannot just demand 15% every year and expect them to appear. You can, but what happens is, if it's easy in the beginning as possible, once it gets a little harder after a few years, you have to find a systematic approach. It just doesn't fall out of the sky anymore. Okay, and the last point, the last big point that we learned was more of a question, actually. In facilities like this, you manage many things. You manage productivity, you manage quality. And for all those things you manage, there is a system for it. There is a methodology. For quality, the Six Sigma perhaps, and for efficiency, there's Toyota production system. Now, what is it for energy management? Right now, there is no methodology for energy management. At least not when we started doing our project 2 years ago. We saw carbon trading, that's one way, but it doesn't really get you to where we want to go, which is understanding the energy in your process and eliminating the waste out of it. So we started doing this ourselves. We decided that we had to base our methodology on something that we knew. This was just our step, our first step. And we took the Toyota production system. The idea of the Toyota production system is you remove waste. You make things more efficient by removing the waste inside. And to do this, you have to be able to see the waste, or you have to see the process. So for example, the 7 things that are considered waste include quality, so rejects, inventory, and to reduce them, you make them visible. So inventory you display as your inventory on the shop floor. Quality you display as rejects. And so we added an 8th, energy, and we tried to make it visible, try to really make it transparent, which, as you know, it's not in a factory. You use energy, you get a bill 30 days later, and you have no idea what happened in between, who used it, when, for what. So we started changing this by installing a company-wide energy management and monitoring system. So this is a picture, a diagram showing the actual system that we have at our factory. In one of the buildings, we have the whole building monitored, over 60 smart meters from each main supply to each zone by business unit to sometimes each individual machines. And the data is collected real time, every 15 minutes, recorded by a system supplied by Saia-Burgess and stored in a centralized database. The system actually took us only about a month to install. It was very, very simple. It was bus-based, so once we installed the meters, there wasn't a lot of programming, and we were up and running within a month. All the data is visualized through the web, so I'll show you a few of the screenshots in a second. Here's the photographs of the hardware. So the meters installed next to our main electrical supply room. The actual equipment, it's all industrial, so it's very, very robust. And you can handle all the extremely high current conditions that we put them in. And the data is available on the web, so our staff can see real time where the energy is being consumed, in which area, and how much. This is critical for them at the first stage to identify, let's say, where the highs and lows. So the information is also available on the computers and the desktops. You can also compare the totals and also by time. And they were also able to use this on the shop floor. This is very, very important. They were able to take this data using their laptops or their iPad, iPhone, and diagnose the machines on the shop floor immediately, not doing it from the office. Now, what did we do with this information? The first thing we did is is kind of like analyzing quality. We collected all the rejects, and we tried to divide them based on where the failures happen. And you have a pile over here for failure number 1, pile over there for failure number 2. And whichever is the highest pile, you look at first. So that's what we did. What were the processes in our factory that were consuming most energy? We plotted everything out through the data, and it was very easy to do, and you can do this in real time. And we found that there were 3. Induction hardening, CNC lathes, and grinding, centerless grinding processes. So we looked at those in detail. What we found was a common theme, actually. We have to understand the need of the process, and we have to understand the machine capability. And usually the machine capability is higher than the need of the process. But this was okay before. But if you want to run an efficient process, you have to remove that extra waste. It's wasted energy, so it suits the process. So we applied this thinking to the various machines. I'll give you an example of the CNC lathe. The CNC lathe machine is designed to machine shafts into worm gears or into screws. And it's designed to handle up to 26 millimeter shafts diameters. Now in that case, you need 3 water pumps to cool it, running full power. Now when you reduce the size of the diameter of the shaft, the 3 pumps are still on all the time. But actually you don't need so much cooling. In fact, because the area is volume, is squared or cubed, you only need 1/3. So we made a simple modification. We narrowed the nozzles of the spraying of the cooling water, of the coolant. We removed completely 2 of the pumps and connected the other 2 hoses to the 3rd pump, and essentially eliminated 66% of the energy consumed during the running cycle of the machine, and we have spare parts for the cooling motors. All this happened over a weekend, and we spent about 100 euros in terms of labor. So it was an incredible amount of payback. We saved 24,000 kilowatt hours per year and around 2,700 euros in the first year. So the value is not a lot, but this is, again, it didn't take a lot of work. It was easy to find that once we identified the high energy usage, and once we were able to break down and understand where the energy is going. So this kind of change, this kind of energy saving is a transparent methodology, sustainable way of doing energy saving. I'll give you another example. Once we were able to identify, let's say this was a grinding machine. The grinding machines had different efficiencies. When we measured all the individual machines, we found that some were better maintained, some are older models, some have newer internal drives, some have smaller servos. So there were different energy consumptions, even though they were working on similar products. So you wouldn't have thought that if you just looked at the machine on paper. And this is what typically people start doing. This is a X kilowatt machine or X watt machine. But when you really measure and look into it, you find that is not the case. And we found that some efficiencies were twice as good as others. So we scheduled the production so that it always used the more efficient machines first. It's not a new idea, but by applying this old idea, we were able to save 1,100 euros, or 99 or 10,000 kilowatts hours per year. So again, this took no investment and was basically natural out of digging deeper into the system. The last example I'm going to give you is timing. Before, we didn't know when we're using the energy, and we didn't really track that. But now that we have real-time measurements of all the energy consumption, we saw that actually we're using a lot of the energy during the day, when in fact we should be using it at night. And before, we were supposed to be using the energy at night, but nobody was checking. So the power of just checking was very strong. So we were able to see that we weren't doing what we were supposed to do. So by correcting that, by scheduling machines to run at night instead of at daytime, we save 14,000, close to 15,000 euros a year. This is only in one of our buildings. So if we were to replicate this across the entire site, it could multiply by 10. It could have a significant impact on the savings, and there's very little investment, and it's just by having more awareness in the people. Just by having more awareness in the people. So altogether, we put all the sums together. Every year, we're going to save about 30,000 euros just from these three things. Okay? And it didn't take a lot of work. It took us, let's say, a month into doing this project to find all these things. And it's going to continue. We're going to break down further the other high energy use. Where is the energy going? How do we reduce it? So on and so forth. So this is a systematic, sustainable way of managing energy and reducing energy through transparency and through accurate data. So you can see here the ROI is all over 100%, so you get payback within 1 year, less than 1 year most of the times. And it's not a huge impact to the company as well. People can still do their jobs. They need to spend extra time doing this work, but it's not like installing a new energy system that affects a lot of people. No, it's very hands-on and very bottoms-up. People can start saving energy just by having this simple data. Now, the third step after this is what we discovered in doing this exercise is not enough to know how much kilowatt you used, because the machine is doing different things different time of the day. It's working on different models. Some are bigger, some are smaller. It will use different energy. So you have to be able to benchmark more accurately. So the next step for us is we combine the ERP data from our production lines with the energy data. And this means you don't just get kilowatt hour, you get kilowatt per product line, kilowatt per component, kilowatt per this kind of shaft, kilowatt per this kind of motor. You can benchmark yourselves, and you can really then dig deeper about where the waste is, where the high potential of energy saving is. This is our vision. We built in-house a prototype that combines the energy data from the energy management system supplied by Saia with our own in-house web display. It's basically a visualization software. And there's some screenshots, and we think this is going to take us to the next level. So I want to summarize what I talked about today. There are three main things you need in energy saving in the long term. You need the equipment, you need the tools. This you can acquire by paying money. This is something that's basic. So you should get something that's easy to use, simple to install, it's not very expensive. You just need a system that will give you good data, accurate data that's easy and simple to use. So Saia served our needs very, very well for this case. And the other two things you need to spend some time in: managing and motivating the people, and creating a methodology that works for your own processes. Because everybody is different. There's no one way to do energy saving. But you need management to spend time supporting the teams. You need to have clear teams defined and targets. But most importantly, just having targets is not enough. You need to give them a method. So all three are linked together, as you can see. And in the end, I think the four main points you should remember from this. The limitation to energy saving is not the hardware. The hardware is already there. It's the software, it's the people's thinking, whether you had the right information so you can make those decisions. If we didn't know that different machines were using different energy, we wouldn't be able to schedule them correctly. If we didn't know that the energy was being wasted inside the pumps, we wouldn't be able to schedule them or utilize just fewer pumps. The other point is you need the methodology, and you don't just use the result. It's very important to have a method. I already said this point before. And the third one is it takes time. You have to be patient. You have to really look at the details. But when you do, and you solve some issues, you can then take that and spread it out and get a lot of savings that way. So you need to be patient and spend the time in doing this. And lastly, you need transparent, accurate data. Because that is what drives your process. That is what tells you what to do next. So you have to have transparent, accurate data. That's very, very important. And lastly, I want to share with you our team. This is the team leaders across the different energy saving groups. And we also did an interview with the person that was working in the plant manager where we installed the system.
The key message for energy management is to be able to make the data transparent. Okay, you can collect the information, okay, and then you can work out how you use the power. Once you have worked out how you use the power, you can then change your mindset, and then you're able to develop new strategies in saving time.
And before I end, just a few tips, because we're here to discuss the industrial machines and industrial automation. A few requirements or a few challenges we had when we first started our work. It was very difficult to collect information within the machine, as you can imagine. We had to take apart the machine because it's not just the pumps inside. There's also the main driver for the grinding, there's a flywheel and so on. So to measure those individually is very, very challenging. And you can't do that unless you're willing to void the warranty on your machine. So it was very difficult. And I think if there were more transparent energy reporting for these machines, it would help us do our work. Number two, we saw that a lot of the machines don't scale very intelligently with the load. So if you give it a bigger product, it uses the same amount of energy as a smaller product. We shouldn't have to do all the work. It should just be automatic to let's say, manage its energy itself. So I hope that these two would be trends coming in the future from innovations from people here. And on that note, I thank you for your time, and I hope that we'll be able to continue to share our experiences in the future.